We have with us this morning a contractor for the Computer Services Corporation at NASA Ames Research Center. She's coming here and bringing awesome weather all the way from sunny San Francisco, California. Ladies and gentlemen, put your hands together for Janice Singh.
Thank you for coming, and I'm going to be talking about the real-world uses for the Nagios APIs. So, this worked earlier. There we go.
Yeah. Can I move the microphone?
Sure.
Thanks. Just kind of put it right in the middle.
So, I'm going to be talking about a little bit about what the Nagios APIs are in case you aren't familiar with them, and how we use them. So I work at the NASA Advanced Supercomputing Center facility at the NASA Ames Research Center, and so just a little bit about how we use them and why I think people should try using them, because so my title is actually systems engineer, but I consider myself more of a programmer. So I was excited to hear that there were APIs. We could use Nagios stuff with code. And so that's really what I want to talk about today. So a little bit about our center. Our big machine is called Pleiades. As you can see, it's got lots of nodes and cores, so we have to monitor that. And they're doing some work on that machine, so either as of last weekend or next weekend, those numbers will be a little higher. We obviously aren't going to have people logging in straight to that machine, so we have front-end systems for the users to log into. We have a Hyperwall visualization cluster, which I forgot to bring the numbers for, but it's basically a whole wall of screens that are used with I think they say it's 250 million pixels to be able to visualize data in different ways. We deal with petabytes of data. So we have tape storage servers that we have to monitor. We have different types of file systems, so those servers need to be monitored. And then in order for the users to be able to use Pleiades in a fair way, we have a portable batch system, so we have to monitor those servers, and we have to monitor the job scheduler as well. So that's just some of the things that we monitor at our center. And we use Nagios a little differently than most places do. We do use some notifications, almost no event handlers. What we use our data mostly for is to create this visualization. And so as you can see, we have different servers that are displayed in different ways. The ones on the top we consider domains. We have information on the file systems, the Lester file system specifically. And I'm not going to get into much detail on this, but if you hover over the different parts of it, you'll get more information, and these do click back to the Nagios web interface. And all this data here we get through using Nagios. So I talked about that. I'm going to be talking about the Nagios APIs. So for those who aren't familiar with what the APIs are, with Nagios 4, they just come with it. You don't have to do any extra setup to get the APIs. They return output in the JSON format, which can be used in multiple languages. There's 3 kinds of APIs, and I will give examples of them later, but archive, object, and status. You run them from the CGI directory, and they have a help query. So I have an example there of how, if you want to know how to use the ones for status, how you would get the help. And if you make a mistake in the query, that's also going to give you a help. And someone can correct me if I'm wrong, but as far as I know, there's no documentation for the APIs, so the help is actually gives you pretty much all the information. And so for anyone who's not familiar with JSON, it was originally made for JavaScript, hence the JS at the beginning of it, but lots of languages support it now. We're using Perl. But one of the things I like about JSON is that it's human readable. If you've never seen it before, you can look at that and probably guess it's about a host group called tools, and those are the hosts that are in it. So I'm going to talk about how we originally did the data, got the data into a format to be able to make the website. So most of the outer part of this should look familiar to anyone who's used Nagios. It's just simply we have a firewall, so anything outside of the firewall we can use NRPE. Or if you're inside the firewall, we have to talk out, so we use the NSCA agent to do it. And then it's on our web server that things are kind of a mess. I actually didn't realize how much customization we did until I actually put this together. So we have something that we created in-house called DATAG, and it stands for Data Aggregator. So it actually gets its information from the pipe file that NSCA uses, and then it sort of just bypasses the whole Nagios one, and then it writes to it. So it's a very strange configuration. And so it had to have its own configuration file that it used in order to make what we call the HUD buffer. So the visualization, it's called the HUD. It stands for Heads Up Display. And so it writes this text file that we call the buffer, and then the website grabs the information from there in order to build it. So it's a lot of extra customization and extra layers that went into making this work. So we knew that we needed to change that, and so we had different ideas we were working on last year, and then I came to the conference and found out that their APIs were coming and decided to change our focus and do it that way. So for multiple reasons I don't really want to get into, we skipped Nagios 3, went straight from 2 to 4. And so just that, doing that upgrade was able to simplify things for us. And as it shows there, it was originally over 17,000 lines of code that we were able to get down to 9,000 just from using some of the features from the upgrade. And part of that was using host groups, which I know was possible in Nagios 3, but we were able to we didn't have to do services for every single host. We could just use host groups. And yes, it did break it into 23 different files, but that does make it easier to manage, actually. And then by using the APIs, we were able to get rid of the DATAG configuration file. So this is our modified data flow, as you can see. So nothing outside changed, but if you look in there, it's a lot cleaner. We're just using Nagios, basically, and we're letting Nagios do what it does without changing things. So that's a big benefit. We changed the name of the daemon. It's nagpop, which stands for Nagios Post Processor. And as you can see, that's the only extra thing that we have to use. And it just gets information from Nagios using the APIs. For right now, we're in phase 1. We're still in beta. And so it still writes a text file that we call the HUD buffer, which writes out to the web. But eventually, we'd like to get rid of that altogether. And then that would be, I guess, the cleanest we could get for our data flow. So, one other thing. So we got rid of we don't use NSCA, but use NRDP instead. And that runs over Apache and just writes straight to the same Nagios pipe file that Nagios writes to. So by doing that, because DATAG needed that second pipe file because it was bypassing some data, by getting rid of that, we were able to use NRDP. And so again, by getting rid of that layer, we're just letting Nagios do what it does. It writes to the web interface, which is what it should do, and it just makes things cleaner. And NRDP allows us to send much larger packets of data, and so in NSCA they were pretty small, and we were sending lots of information, so we'd have to split it up and then reassemble it on our web server. And so with NRDP, I at first got rid of that altogether, but we do have one plugin that returns so much data, it actually hits a kernel limit, so I'm going to have to do the whole split and reassemble thing anyways. And the other thing is that NSCA, or I'm not sure if it really was a drawback of NSCA or just the way the person who originally did it designed it, but he overloaded the performance data section. And so for those who are new to Nagios, if when you send output, after your output there's a pipe symbol, and then this portion's called performance data, and it's basically in a variable equal value type format, and it can be used for graphing, and Nagios collects that data and you can do metrics with it. Well, we actually can't because that is overloaded with information sent. So now we can clean that up and in the future be able to use that a feature of Nagios. So I mentioned there are 3 types of APIs, and so the one kind is archive, and so that gives you the historical information on things like availability, alerts, notifications, and you can give it the timestamps of how long you want to be checking for. So in this case, doing a query, this is an example query, and you can find the, so this is behind a firewall, so don't actually try using this one. And so this can get us the availability for this particular host, and the start time, you can give it a date format or a date, or you could give it in if you give the minus sign, it'll tell you that many seconds ago. So that happens to be the number of seconds in a week. And then this is for the object, JSON or API. So this will give you pretty much whatever is in your Nagios configuration. If it's in there, you can get it through the object JSON. So hosts, services, contacts, however you've set up Nagios. So this example, it's the one I showed you the JSON for earlier. It's the this shows you all the host groups in that particular, or all the hosts in that host group called tools. And then the status API does what you would expect it to. It gives you the status of host, service, comments, downtimes, whatever status there is that you can find, you can get it with this. And then this would be the same as the last one. It tells us but this would give us the actual status. Are those hosts up, down, or unavailable? And then there's that enumerate part, because when you get an output in Nagios, if you've ever written a plugin or you're familiar with that, you know that 0 is okay, a 1 is warning, 2 is critical, and 3 is unknown. But the output you get from the API seems to be based on binary, and so the numbers are going to be different. So if you're doing something human readable, you can just use the enumerate option I mentioned, and you'll actually see pending, okay, warning, or it'll be in text. But in code, you generally want to use the numbers, so I just included this little chart in case you wanted to see how the numbers corresponded. And pending doesn't technically have a number in Nagios if you're using a plugin, but we need pending for our visualization, so we just assigned it 6. So there's an API GUI tool that helps you to be able to build the queries that you have, to figure out what variables you want to put. It's really helpful when you're just trying to figure things out, because you as you choose things, the drop-downs tell you what the relevant variables are, what you need to put. Then after you hit submit, it will display, it builds the query, it displays it, it executes it, and it shows you the JSON. So I find that very helpful to put it together. I like using it just to see the JSON output and use it for debugging actually more than I use the web interface. And if you hover over any of the input values, it gives you tips on how to build it. So in order to get to it, it's just your normal Nagios, and then afterwards it's JSON query.html. So here's an example of what it looks like. Here, I'm just trying the object JSON with the host group, and here the only thing that was required was the actual host group, and then on the other side you see the query, and I didn't show all of it, but the JSON output would be there. And then here's an example of if you wanted extra information, that's hovering over the date format, and then it gives you the extra information. So if you're new to the APIs, you want to figure out how to use them, this GUI tool is extremely helpful. So how we use the APIs. So we have our new daemon, nagpopd, which I couldn't get people to actually use that name until I wrote this presentation, so that was helpful. And so we use the APIs for the object model and for the status. And then another thing we do that I'm going to talk about is how we handle scheduled downtime, because that uses an external program. So it's an example of how you can use Nagios to talk to other programs. So we use the object JSON to get all the structure of Nagios. So that means we no longer have to have that separate configuration file that was used by DayTag. And so having two configuration files is always a bad idea. So for one thing, it's just inefficient because you're having to double everything you do. It's more places for you to be able to make mistakes. So there's more errors come in, and sometimes you're in a hurry and you don't do both of them correctly, and then you never go back and fix it, and so it's just, then things get to be a big mess. But here, we just use the Nagios configuration only, and anything that did need to go into the configuration for making the website, the HUD, we can just put that in the Nagios configuration. So like the bigger ones were called domains, we can just put that in the configuration for Nagios itself. So we did use the notes field to do that. So we overloaded some of the current directives that are in Nagios, and then we used custom variables, which we just put an underscore in front of the directive name, and then you can use anything you want. So then what it does is it writes out to that HUD buffer. And so we use the objects that we just get from the API queries. We use Perl, because we use Perl for just about everything, but any object-oriented language you could do this with. And so basically the first part where we suck in all the Nagios information, it could be used for anything. It doesn't necessarily have to be used just to write out for the HUD buffer, because it's pretty generic. It's just pulling in all the information. And there are certain services that we do special handling with, so we just handle that with subclassing. So it's less work because we're using the object-oriented approach to it. And then, as mentioned before, we do use custom variables such as the domains, and we just named it multi-service group, but basically some of the service groups that we have aren't specific for a host, but it might be specific for, say, a file system, and it comes from different hosts, and so we handle them a little differently. So that's just some of the customization, but it's not a whole lot. It is mostly based just from what we can grab already in Nagios. So for those who are interested in object-oriented programming. This is our object model. It's very simple. As you can see, the objects are really just what we're getting from Nagios. And I did mention how much I didn't want extra configs, and there is a config there, but it's really simple. It's just basically where the files are located, where we want to write it out to, so it's not, I mean, those are some things you can't avoid. It's as basic as it can get. And for those, again, who are interested in object-oriented, those are the subclassing that we do with the services. And we just, if there is a service that needs the extra handling, we put it in the service to object. And so that way we're not doing any if-else. The object-oriented model just handles that. And this is similar information, just in text form. So the default process, it gets the information from Nagios, doesn't make any changes, and then the output is it writes it out for the HUD buffer. But we could do anything else. We're planning on doing it in JSON, just so that for us, the HUD buffer is readable, more human readable. But as I mentioned earlier, we'd like to write it just straight to HTML, skip having an in-between buffer. And you could do anything else you wanted with this. If you wanted to write it out to a particular database, MySQL, if you had something that needed to send out to anything else, you know what you could use it for. I don't know what you guys do. So, and again, the subclassing that I mentioned, so it's just for very special services, like we write out the data for the free space on disk space. Separately, we format it a little differently, so that's one example of just a method we would drop in to change the format. So these are the API queries we use. So we found out that it was actually quicker for us if instead of using the APIs to get different types of information, we just grabbed everything in one API. So this just gets us all the hosts, how we've set them up in groups, how we set up the services, and we just do that the first time the daemon starts up, and then we have the configuration file. And then in a loop, we get the information, what the current information is from Nagios, and we use that to update our data. And one of the things I like about using this is that in this case, we're doing a pull. We're just getting what is the current snapshot of the information at any given time, whereas in our previous one, it was a push. So we had to wait for data to get updated before we would see anything. And it mostly at restarting the daemon is when we would notice problems because of that. And then in case one of these JSONs has an issue because the input from one of the plugins causes issues, then the error checking, then we would do things individually, like maybe get it for a particular service group or something instead of just trying to get everything in case there's a problem with one of the plugins. So then the other way that we use the APIs is in handling scheduled downtime, because Nagios has its scheduled downtime, and then we have a separate external program that's used, it's called Schedule, for getting our downtime. So our old way of doing it, and I don't know how much of this was just bad design or because we didn't have a better way of doing it, was actually editing the downtime log, which I know that was wrong because at the top of it, it says don't edit this. So one of the things that Nagios does, which makes a whole lot of sense, is that when a host is down, Nagios is going to, it says stop checking it, which is wrong. It stops checking the services in it, which makes sense. If the host is down, of course, the services are going to be down. But we needed to be able to tell at any given time if the host was in scheduled downtime or not. So the way it was set up was to make a second host with it that it would just have the first letter capitalized. And that one, Nagios would never think it was down no matter what. The the plugin that checked for it, it was called OK.sh and literally just said everything is okay. And now we use the APIs for this. So here's the external program. It's really simple. It's schedule all, and then it tells you the hosts that are down, when it'll be down, and why, which is basically the same thing that would be in the Nagios downtime. So what I created a little script that it gets the information from schedule. It sees what's already in the Nagios downtime. If there's something in schedule that's not in the Nagios downtime, then I want to merge it. So the way to do that is using the external command feature. So this isn't new, but it's a way to talk to Nagios. So there's one for schedule host time, and as you can see there, the first one shows what the variables are, and the next one's an example of putting it into downtime. And what you do is you basically print out that text and you redirect it to the Nagios command file, and that puts it into Nagios. And so basically this thing that we do with the scheduled downtime, the way we handle it, so it uses APIs to grab information from Nagios, and it uses the external command feature to write into Nagios. So basically anything that you want to communicate with outside of Nagios, you have a way of grabbing information from Nagios, and you also have a way of sending information in. So it makes that communication, well, I know that the website says old.nagios.org, but that seems to be current information. So if you want any more information on what different commands you can use for external commands, that's where you can get it. So of course, anytime you do things, there's going to be problems. So the Nagios support team has been great about looking into things and fixing them. And the one with percent signs breaking the JSON, it actually, when we went to decode the JSON, the script just flat out broke. And so actually it was good for us because we hadn't actually thought about how we were going to handle it when something went wrong, when we couldn't decode it. So that actually when we started figuring that out. And then the JSON output, at first it was only 8K, and I mean, as I mentioned, I have one plugin alone that hits a kernel limit, so that 8K thing was going to be a deal breaker. So I was really thrilled when that got fixed rather quickly. And our latest saga was working on the new lines that didn't show up, but I haven't fully tested that, but as far as I know, that one is fixed now. And then other sort of things, I've mentioned this, that there is kernel limitations that I need to take into account. So I still have to do the breaking up of data, putting it back together. And then because this is the one using the API is still in beta, we have to have the production one working at the same time. So we're using NSCA and NRDP at the same time. And it really shouldn't be that difficult to put them together. It's just in one script, send it through NSCA, another script, send it through NRDP. But because of overloading the perf data, and I don't want to send that kind of mess to our Nagios 4, it's having to figure it out and put things in the right place that got really frustrating, and that's why the duck is there. So in the future, as I mentioned, we'd like to write just to the HTML, and if we can use AJAX to only update what needs to be updated, that would be the ideal situation, what we're trying to get with that. And in the previous way that we did things, there wasn't a whole lot of information I had from Nagios, but now with the APIs, anything that's there, I can get. So for example, if someone acknowledged a service, I had no way of being able to get that information. Now I can pull that and we can update it so it makes the visualization. We don't have as much extra color there that doesn't need to be there. And then if we can use the archive data, and some things it's better to alert on trends, how much they've changed. Other things like the host up or down, I mean, that's not going to be based on a trend, but some things might be useful, and I can see using the archive data for that. So basically, being able to use the APIs has simplified things greatly for us. We're able to use the object model. We have less configuration, and our processes, as you saw from the boxes, are far simpler now to do this, and had great customer support, which is the way that this has been possible. So does anyone have any questions? I think we need mics.
Do you happen to know, is the object JSON API parsing status.dat, or is it looking at the config files, or where is it getting its information?
I think the developers would be better to answer that question than me. I don't know.
I can answer the question. It is still parsing the status.dat file.
Put it in a RAM disk would be so favored. I found it's much better to put status.dat into a RAM disk and then decrease the interval for polling on it, especially if you're looking for data every like 10 seconds.
Who has other questions for Janice? Okay, up here.
I was curious if you're going to open source your Perl API for dealing with the whole Nagios object models.
When it's not in beta, send me an email, as I have to jump through hoops to do anything like that, but I would definitely be interested in doing that. So just shoot me an email, and I'll let you know how that works out.
The HUD picture was quite impressive for a complicated system to make it look simple. Do you have any advice?
On making.
I want to replicate that in my environment. Mine's obviously a lot simpler, but it's a simple picture that describes a complex system very well.
Yeah, so it comes down to what are the main things that you need people to see right away. Ours was there's the daemons and the disk space, as file disk space is one of the biggest things for us. And so that's why for most of the systems, it's one box per system, and those were the two things that have a special box for people to see. And so it really comes at what's important for you, what do you need to see, and basically grouping them into categories was the biggest thing. So for the systems that have our job scheduler on it, information about the job scheduler would be what was critical on those. So then they have their own little box. And so it's just grouping it based on what's important to you at your center. What's the thing that you want to notice right away?
I mean, in the presentation, you used the term domains for the top. So were they failure domains?
No, I don't know why the term domain came. It's from something legacy while I wasn't working there. And so, no, it's just, it's just a kind of cluster, basically.
Okay, cool.
You use the API to get data, but does it lack the post option to, instead of using the external command to set a downtime?
As far as I know, that's the only way to set the downtime. Is there? Okay, they're nodding back there, so I guess so.
I was just confirming, yeah, you will need to use the external commands to set downtime.
Is that true in general of anything, any control you want to, anything you want to send to it? All right.
Other questions for Janice? Again, keep in mind all of these sessions are being recorded, so even after the event, a couple of weeks or so afterwards, they'll get them up online, and so you can reference back. Not only will you be able to watch that, but you'll be able to have Janice's contact information, so if you had other questions at that time. Ladies and gentlemen, one more time, a nice round of applause for Janice Singh.